Alright, let's go over the 2.5 homework. Number 1, movies length represents the first quartile for movies showing the theater. Make an observation about the movie's length. So if the movie's in the first quartile, and it's in the bottom 25% of movie lengths, and so make an observation about it, you'd simply say it's a short movie. Done. A student's score on an actuarial exam is in the 83rd percentile. Make an observation about the student's exam score. Student scored better than 82% of other students. So the student would have scored better than 82% of the other students. Exercises 7 through 10 determine whether the statement is true or false. If it's false, rewrite it as a true statement. About 1/4 of a data set falls below Q1. That would be true. The second quartile is the mean of an ordered data set. That would also be true. Well, really, yeah, that's true. It's the top of the second quartile that makes the mean. An outlier is any number above Q3 or below Q1. That would be false. Remember, your interquartile range is found by doing Q3 minus Q1. Then you do 1/2 times the interquartile range, or IQR. Subtract it from Q1. It's not any number that falls below it. It's any number that falls below Q1 minus 1.5 times IQR. It's impossible to have a z-score of 0. That's false. That's just the median, or the mean. Sorry. All right. Should put the directions for 11 and 14 so I knew what I was supposed to do. Give me a minute. All right. So I have to find the quartiles, the interquartile range, and identify any outliers. So I'm going to go into stat, edit, clear my list one out, and I just have to enter the numbers. Okay. So now I've entered those in. Go over to calc, one var stats. I can find my quartiles by just scrolling down. So Q1, 67, median is 60, Q3, 63. Might as well list your min, 51, and your max, which is 80. Okay, find the interquartile range. All you do is do Q3 minus Q1. So IQR is 6. Then to identify any outliers, you do 1.5 times IQR so 1.5 times 6 gives you 9. Then you do 57 minus 9. Now anything below that would be a outlier. Since our min is 51, we already know that it's not going to be, that there's nothing below that. And so you're good. So no outliers on the low side. Now to find if there's any outliers on the high side, you do 63 plus 9. That'll give you 72. Any number above 72 is an outlier. Let's look back at our original data set. And our max is 80, so that's your only outlier. Alright. So number 14. Doing the same thing here. Just different set of numbers. And so we go back into stat, edit, clear it out. So you go up to L1, clear, push back down, should clear out. And you enter your new numbers in. Okay, so it's all 20. Stat, go over to calc, one var stats, scroll down, you get that the min is 19, Q1 is 21, the median is 22.5, Q3 is 24, and the max is 29. Then we do Q3 minus Q1, that would be 24 minus 21, which should give you 3. Do 1.5 times 3. So IQR is 3. 1.5 times 3 gives you 4.5. Let's do 21 minus 4.5. We're looking for any outliers now. That's going to give us, I have no idea. That's sad. 16.5. Since our min is 19, there's nothing below that. Now we have to look for an outlier on the top side. So we take Q3, which is 24, and you add 4.5 to that, and it gives you 28.5. Then 28.5, looking for any number that's bigger than that. The only one is 29, so that's your only outlier. All right. Exercise 16. Okay, this one's an easy one. We just have to identify the 5 number summary. So your min is 100. Q1 equals 130. Your median is 205. Q3 equals 270. and your max is 320. That's all you had to do for that one. Okay, draw a box and whisker plot. In exercises 17 through 20, find the 5-number summary and draw a box and whisker plot that represents the data set. So, just go right back into your calculator, find the 5-number summary, stat, edit, clear it out, put the numbers in. No, I see already I messed up. 170. 178, 181, and 180. Okay, push stat over count. One bear stats. Enter. Scroll down and get your 5-number summary. So we have 150, 172, 177, 180, and 182. My mom. Okay, so as you can see, I constructed my box and whisker, or well, my number line for my box and whisker plot. Now all I have to do is actually construct the box and whisker plot. So 150 is my bottom number. Then I have 172, that's Q1, 177 is my median, 180 is Q3, and 182 is the top. So now I draw my box. My little lines. And that's it. Alright. Number 22 says, use the box and whisker plot to determine whether the shape of the distribution represented is symmetric, skewed left, skewed right, or none of these. Justify your answer. This one would be skewed right. And reason for that, 75% of the data falls between 20 and 40, and our box and whisker plot goes up to 80. Number 25. Use technology to find quartiles and draw graphs. Basically the same thing we just did. We're going to go into stat again. Figure it out. And start entering values in. 2, 4, 1, 5, 7, 2, 5. That was not a 5. stat count, one bear stats. Enter. I can scroll down. Look at my min, Q1, median, Q3, and max. So my min is 0, 2, 4, 5, and 9. Pull a number line over. Make it 0, 2, so the bottom number would be 0. And we would have 2, 4, 5, and 9 would just be a dot. Looks like that. All right, number 31. Height represents the 60th percentile. We have 60th percentile is here. That would be 70. So you would say between 70 and 71, or you could just say 70. That would be fine. Which height represents the, and that means that 59% of the people are shorter than 70 inches tall. Well, 59% of adult males are shorter than 70 inches tall. Which height represents the 80th percentile? That would be 72. Very similar interpretation, just so we know how we're getting that. We're going up to the 80th percentile, coming over and seeing where it matches up down here. That would be that this guy is taller than 71% of the people. What percentile is a height of 73 inches? You just go over 73, go up to the percentile rank. It would be about 90. And what percentile is a height of 67 inches? That would be a little more than 20, so maybe 21. Finding percentile, use data set which represents the ages of 30 executives. Find a percentile that corresponds to an age of 40 years old. So for us to figure out what this percentile is, we first have to know how many executives there are. There's 30, right? Then figure out how many are below the age of 40. So just looking through the data. None, 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 none. There's 1. There's 2. 3. Now it's not age 40, it's below the age of 40. So you don't have to worry about that one. So there's 3. So you do the number below 40 divided by the total number. And then times 100, obviously. 3 divided by 30, which is 1/10 times 100. So this is going to be 10%. So 10% of executives are under the age of 30. Next we have this z-score, and we have to be able to tell which is which. Now remember, z-score is just a standard score to figure out how far a data point is away from the mean. Alright, so which one is which, A, B, and C? There's our mean right here. Okay, so what's closest to that would be the 0.77. So that would be B. 1.54 is above it. You see, negative 1.54 is below the mean. So that would be A. So it would be BCA. Okay, let's find the z-scores for Jan Ullrich, Cadel Evans, and Henry Cornet in this distribution of the age of winners of the Tour de France. So the mean age is 28.1 years with a standard deviation of 3.4 years. So really, in order to do this, you do x minus x bar over s or sigma. Remember, x bar is your mean, x is whatever your number is. So it'll be 24 minus 28.1 over 3.4. You just put that in your calculator. You get 4.1 divided by 3.4. So your first one is going to be negative 1.2. Just do z equals negative 1.2. And that tells you that it's 1.2 standard deviations below the mean because of the negative. All right, Cadel Evans. Do 34 minus 28.1 divided by 3.4. It's going to give you 1.74. So that's pretty close to 2 standard deviations above the mean. Then the last one is Henry Cornet. So you do 20 minus 28.1 divided by 3.4. Now this one's going to be out there. So if we do negative 8.1 divided by 3.4, you get negative 2.38. That's good because it shows you that it's over 2 standard deviations below the mean, which puts it in that lowest category if we're thinking about the empirical rule. Alright, Last one. Comparing Z-scores, the table shows population statistics for the ages of Best Actor and Best Supporting Actor winners at the Academy Awards from 1929 to 2013. The distributions of ages are approximately bell-shaped. In exercises 49 through 52, compare the Z-scores for the actors. And this is a case where we compare Z-scores because there's no way to compare Best Actor to Best Supporting Actor when their age differences are so far out there. So the easiest way to do this is you do Jamie Foxx first for Best Actor. Z equals 37 minus 44 divided by your sigma, which is 8.8. You can set up Morgan Freeman's too. It would be 67 minus 50 all over 14.1. Okay, whenever you do Jamie Foxx's, you get negative 0.795 or negative 0.8. Whenever you do Morgan Freeman's, you get 1.21. Okay, then when you look at the Z-scores and how they compare, Jamie Foxx was almost one standard deviation below the mean, and Morgan Freeman was about, well, a little over one standard deviation above the mean. Knowing that, you could say that Jamie Foxx was much younger whenever he got his award for Best Actor than Morgan Freeman was in comparison for Best Supporting Actor. Alright, that is it for today. You can get your packets out for your Chapter 2 study guide. We're going to be taking that test this week, Wednesday, Thursday, and Friday if you need it. Alright guys, nice job.